nebula is an interstellar cloud of dust, hydrogen, helium and other ionized gases. Originally, nebula was a name for any diffuse astronomical object, including galaxies beyond the Milky Way. The Andromeda Galaxy, for instance, was referred to as the Andromeda Nebula before the true nature of galaxies was confirmed in the early 20th century by Vesto Slipher, Edwin Hubble and others. Nebulae are often star-forming regions, such as in the Eagle Nebula. This nebula is depicted in one of NASA's most famous images, the Pillars of Creation. In these regions the formations of gas, dust, and other materials clump together to form larger masses, which attract further matter, and eventually will become massive enough to form stars. The remaining materials are then believed to form planets, and other planetary system objects. Observational history. Around 150 AD, Claudius Ptolemaeus recorded, in Book 7-8 of his Almagest, 5 stars that appeared nebulous. He also noted a region of nebulosity between the constellations Ursa Major and Leo that was not associated with any star. The first true nebula, as distinct from a star cluster, was mentioned by the Persian Muslim astronomer, Abd al-Rahman al-Sufi, in his Book of Fixed Stars. He noted a little cloud, where the Andromeda Galaxy is located. He also catalogued the Omicron Velorum star cluster as a nebulous star, and other nebulous objects, such as Brocchi's cluster. The supernova that created the Crab Nebula, the SN 1054, was observed by Arabic and Chinese astronomers in 1054. On November 26, 1610, Nicolas Claude Fabry de Piraeusque discovered the Orion Nebula using a telescope. This nebula was also observed by Johann Baptist Cizat in 1618. However, the first detailed study of the Orion Nebula wouldn't be performed until 1659 by Christian Huygens, who also believed himself to be the first person to discover this nebulosity. In 1715, Edmund Halley published a list of 6 nebulae. This number steadily increased during the century, with Jean-Philippe de Cheseaux compiling a list of 20 in 1746. From 1751 53, Nicolas Louis de Lacaille catalogued 42 nebulae from the Cape of Good Hope, with most of them being previously unknown. Charles Messier then compiled a catalogue of 103 nebulae by 1781. His interest was detecting comets, and these were objects that might be mistaken for them, wasting time. The number of nebulae was then greatly expanded by the efforts of William Herschel and his sister Caroline Herschel. Their catalogue of 1,000 new nebulae and clusters of stars was published in 1786. A second catalogue of 1,000 was published in 1789 and a third and final catalogue of 510 appeared in 1802. During much of their work, William Herschel believed that these nebulae were merely unresolved clusters of stars. In 1790, however, he discovered a star surrounded by nebulosity and concluded that this was a true nebulosity, rather than a more distant cluster. Beginning in 1864, William Huggins examined the spectra of about 70 nebulae. He found that roughly a third of them had the absorption spectra of a gas. The rest showed a continuous spectrum and thus were thought to consist of a mass of stars. A third category was added in 1912 when Vesto Slipher showed that the spectrum of the nebula that surrounded the star Merope matched the spectra of the Pleiades open cluster. Thus the nebula radiates by reflected starlight. In about 1922, following the Great Debate, it had become clear that many nebulae were in fact galaxies far from our own. Slipher and Edwin Hubble continued to collect the spectra from many diffuse nebulae, finding 29 that showed emission spectra and 33 had the continuous spectra of starlight. In 1922, Hubble announced that nearly all nebulae are associated with stars, and their illumination comes from starlight. He also discovered that the emission spectrum nebulae are nearly always associated with stars having spectral classifications of B1 or hotter, while nebulae with continuous spectra appear with cooler stars. Both Hubble and Henry Norris Russell concluded that the nebulae surrounding the hotter stars are transformed in some manner. Formation. Many nebulae or stars form from the gravitational collapse of gas in the interstellar medium or ISM. As the material collapses under its own weight, Massive stars may form in the center, and their ultraviolet radiation ionizes the surrounding gas, making it visible at optical wavelengths. Examples of these types of nebulae are the Rosette Nebula and the Pelican Nebula. The size of these nebulae, known as HII regions, varies depending on the size of the original cloud of gas. New stars are formed in the nebulae. The formed stars are sometimes known as a young, loose cluster. Some nebulae are formed as the result of supernova explosions, the death throes of massive, short-lived stars. The materials thrown off from the supernova explosion are ionized by the energy in the compact object that it can produce. One of the best examples of this is the Crab Nebula, in Taurus. The supernova event was recorded in the year 1054 and is labeled SN 1054. The compact object that was created after the explosion lies in the center of the Crab Nebula and is a neutron star. Other nebulae may form as planetary nebulae. This is the final stage of a low-mass star's life, like Earth-Sun. Stars with a mass up to 8-10 solar masses evolve into red giants and slowly lose their outer layers during pulsations in their atmospheres. When a star has lost enough material, its temperature increases and the ultraviolet radiation it emits can ionize the surrounding nebula that it has thrown off. The nebula is almost 97% hydrogen and 3% helium, plus trace amounts of other elements. Types of nebulae. Classical types. Objects named nebulae belong to four major groups. Before their nature was understood, galaxies and star clusters too distant to be resolved as stars were also classified as nebulae, but no longer are. H2 regions, large diffuse nebulae containing ionized hydrogen, planetary nebulae, supernova remnant, dark nebula. Not all cloud-like structures are named nebulae. Bigger-Hero objects are an example. Diffuse nebulae. Most nebulae can be described as diffuse nebulae, which means that they are extended and contain no well-defined boundaries. In visible light, these nebulae may be divided into emission and reflection nebulae. Emission nebulae emit spectral line radiation from ionized gas. They are often called HII regions. Reflection nebulae themselves do not emit significant amounts of visible light, but are near stars and reflect light from them. Similar nebulae not illuminated by stars do not exhibit visible radiation, but may be detected as opaque clouds blocking light from luminous objects behind them. They are called dark nebulae. Although these nebulae have different visibility at optical wavelengths, they are all bright sources of infrared emission, chiefly from dust within the nebulae. Planetary nebulae. Planetary nebulae form from the gaseous shells that are ejected from low-mass asymptotic giant branch stars when they transform into white dwarfs. They are emission nebulae with spectra similar to those of emission nebulae found in star formation regions. Technically they are HII regions, because most hydrogen will be ionized, but they are denser and more compact than the nebulae in star formation regions. Planetary nebulae were given their name by the first astronomical observers who became able to distinguish them from planets, who tend to confuse them with planets, of more interest to them. Our Sun is expected to spawn a planetary nebula about 12 billion years after its formation. Protoplanetary nebula. A protoplanetary nebula is an astronomical object which is at the short-lived episode during a star's rapid stellar evolution between the late asymptotic giant branch phase and the following planetary nebula phase. During the AGB phase, the star undergoes mass loss, emitting a circumstellar shell of hydrogen gas. When this phase comes to an end, the star enters the PPN phase. The PPN is energized by the central star, causing it to emit strong infrared radiation and become a reflection nebula. Colaminated stellar winds from the central star shape and shock the shell into an axially symmetric form, while producing a fast-moving molecular wind. The exact point when a PPN becomes a planetary nebula is defined by the temperature of the central star. The PPN phase continues until the central star reaches a temperature of 30,000 kelvins, after which is it hot enough to ionize the surrounding gas. Supernova remnants. A supernova occurs when a high-mass star reaches the end of its life. When nuclear fusion in the core of the star stops, the star collapses. The gas falling inward either rebounds or gets so strongly heated that it expands outwards from the core, thus causing the star to explode. The expanding shell of gas forms a supernova remnant, a special diffuse nebula. Although much of the optical and X-ray emission from supernova remnants originates from ionized gas, a great amount of the radio emission is a form of non-thermal emission called synchrotron emission. This emission originates from high-velocity electrons oscillating within magnetic fields. Notable named nebulae. Nebula catalogues, GUM catalog, RCW catalog, Sharpless catalog, see also, HI region, H2 region, List of diffuse nebulae, Lists of nebulae, Molecular cloud, Magellanic clouds, Messier object, Nebulean fiction, Orion molecular cloud complex, Timeline of knowledge about the interstellar and intergalactic medium, references. External links, Nebulae, SEDS Messier pages, fusedweb.pppl.gov, information on star formation, geocities.com, clickable table of Messier objects, space-and-telescope.com.